Hello everyone, welcome to today's Novedge webinar, Civil 3D Pipe Design, Get Productive. In this webinar, we will focus on the top 5 ways to boost your Civil 3D pipe designs with Urbano Visio. Number 1, set a uniform pipe invert flow for multiple pipes. Number 2, set a uniform structure sump depth for multiple structure. Number 3, change the pipe diameter for multiple pipes. And number 4, calculate trench volume estimates. And finally, create data-rich IFC models. They're exciting. And today's presenter, let me introduce you Mihael Vaic. He's the expert manager for Urbano software at StudioARS. If you're looking for best practices to increase productivity, optimizing workflows, and adding value to storm and sanitary sewage design, he's your guy. And let me tell you now a little bit about Novedge. Novedge is one of the largest online stores for design software. We offer a huge assortment of software solutions for virtually every designer's needs. So you can come check us out at novedge.com. And for daily software news and limited time promotion, you can find us on all the social medias, you name them. And I want to remind you that I'm recording this session, so I will post the recording later today on our Vimeo and YouTube channel. Just search for Novedge. And now let me show Mihael's screen so he can lead you through the workflow in Urbano Visio. Take it away.
Okay, Barbara, thank you very much. Just a short introduction. Today I will focus on the top 5 ways to boost your Civil 3D pipe network design with Urbano Visio. So Urbano Visio is an add-in for Civil 3D. So Barbara already read the agenda. So we will be showing a few things. The first one is how to change pipe diameters for multiple pipes. Anybody that's working with Civil 3D knows that this is a long wish, a long issue, call it what you will. It's again on the Autodesk User Group International wish list for 2018. It's on the forums for Civil 3D. All the time people ask how to solve this question or this issue. So with the right tools, it's very, very easy. And of course, there will be a few other things. So just a quick overview. Urbano Visio is a set of 12 tools. And today I will be showing just some functions of 4 tools. So there's lots more to explore and check out. And talking about this, when you go to the Novedge store, you can not only watch videos and read function descriptions and so on, but you also have a download tab where you can download the trial. There's a 15-day free trial included. It's automatic, it's easy to activate, so go to the Novedge store, download it, and try the program for yourself. And if you have any questions, then get in touch with us. Okay, so let's see how this looks. So this is Civil 3D. It's it's a small design, and you can see Urbano Visio is right here in the ribbon. So I will go on and just start the first function for analyzing and editing data. And you see a data table or a spreadsheet open up below, and it's actually, it has some similarities to an Excel spreadsheet, but it's tailored for pipe networks, and there's all sorts of things you can do with it. So first of all, you can pick your different pipe networks. So if you go here on the left side, you can see I have three. The same three are displayed also here. As soon as I switch the network, the data table, the spreadsheet reloads, and it shows the information for this specific network. I can also do this, change this by picking in the drawing. The second interesting thing is I can actually zoom in, so to speak, to some specific items. So I can, for example, select one or several specific pipes, or I can, for example, select a whole pipe run, or I can go and select a specific profile. All these things. Then there's also the thing we call configurations. So you can create any number of data configurations, and you can switch them just as easily as clicking on them. So you can have, as I said, as many configurations as you like for the pipes and for the structures, and you can have different data inside of each of these configurations. So in effect, you can have a different spreadsheet with the data you need, and you can, of course, visualize all of this data. So if we go here, let's say we select this pipe, you see directly that which pipe, which data for which element you are looking at, and just by double clicking you can essentially change any value of this pipe. So for example, in this case, the style or the rule set or the description, or if you go into shape, you can actually end up in your part list and change the pipe. There is also a different possibility, which is perhaps simpler, and that is when you want to change a pipe, just to look for the inner diameter. So here we see that everything is labeled. This is great. So this pipe is a 15-inch pipe, and let's say that we want to change it. So just double click, and you get a list of the pipes of the various sizes for this pipe type. From the part list, you select a different type, for example, the 18-inch. It's changed. If you look at the label, it's also changed, and as well here on the label for the structure. We can also prove this in a different way. So we can go to the profile, and when I look at the profile, also the label for in the profile also now displays the this changed size. Okay, so this is quite simple. So how would you change multiple pipes? This is the interesting thing. So for example, I can select this whole branch. Now I get all of my pipes here. So I can select these three pipes, which are also 15-inch size pipes, and I just go to edit value. Again, do exactly the same thing as for one single pipe, and if I inspect, everything is now changed to 18-inch. Okay, And again, we can go to the profile just to check it out. And of course, everything is updated here as well because Civil 3D is dynamic. Okay, so let's go back to the plan view. The important thing is this way of swapping values, editing, changing for one, for several, for all of your objects is the same for any value that can be edited. And Urbano Visio shows you directly what you can edit and what you can't edit. So everything that's grayed out is essentially something that Civil 3D is calculating or is taking from the graphic, from the drawing. So this value, for example, you can't change numerically. You have to change it in the drawing. Everything that's in a white column can be changed. So, for example, if we want to take a look at structures, for these four pipes, you can also see in a similar way to pipes. Also, you can work with structures. And whenever I select something in this spreadsheet, it will also show in the drawing. And I will just zoom into the profile because it's a little easier to do. And for example, if I want to change the sump depth of the structures, again, I go always to edit value. It's always the same. I can change it from 0 to 1 foot. And as you can see, the structures immediately refresh, and you know, they extend also in the design. You can see the height also changed, and of course you can do this as many times as you want. Okay, so it's quite easy to take it back. So it's very simple, and in this way you can change, as I said, any value, numeric or text, or you know, description, or for example this control by depth or by elevation, or any value that Civil 3D allows you to play with. And the best thing with all of this is that it's quite simple to create your own spreadsheet with data. So just go to editing and say, for example, something like this, my data, and we can just very quickly say, for example, start structure, end structure, and for example, start cover, end cover, minimum cover, and maximum cover. So in this list, you have all the values that exist in Civil 3D, including any label expressions you made, including any object data you made, including property set data. So everything all kinds of data you have in Civil 3D, all can be accessed through this interface. Okay, so we can leave it like this, and immediately it's working immediately. So in this case, it's showing the start cover, end cover, minimum and maximum cover for these 4 pipes. But again, I can just switch it over to show the whole system. I can go over to the storm sewer and watch, you know, look at the data here. So it's quite simple, quite fast to do. I can also, you know, there's also a few additional tricks. So, for example, I can quite easily create an AutoCAD table. So from every spreadsheet, from every this configuration that I made, I can create an AutoCAD table. And also, if I copy this value and go to Excel here, so I can very easily just copy all of my data from this Urbano Visio spreadsheet to the actual Excel spreadsheet. Okay, so that's it, and I can use it on as I said, I can use this with any configuration I created. So any of these small spreadsheets for structures and for pipes. Okay, now let's move on to the next topic, which is improving your IFC exports. So you certainly have heard about IFC. It's very quickly becoming like a standard format for data exchange in a BIM process, in any kind of automated, connected, modern digital process. Call it what you like. So it's becoming very important, and so therefore it's also important to have the best experience, if you like. Civil 3D allows you to create an IFC file from a Civil 3D drawing, but unfortunately it's not possible to get all the data that you have in Civil 3D to the IFC export. So data like generally almost all Civil 3D data, so data like slope or inner diameter of the pipe or anything, elevations, depths, and so on, it's not possible to get out of the box to go to the IFC. Thankfully, we have a tool called Property Set Data Manager, and this allows you to create property set data and to copy Civil 3D data to property set data, and the IFC export, which is built into Civil 3D, will then take all of this property set data with you. So I'm going to create a new data group, and I will just add some values. So for example, again, I have this selection. I will choose network name, then the actual pipe name, then for example, the slope, and the 3D length, and one more. I will take the inner diameter. Okay, so again, you can export three data, 5, 10, 20, whatever you like. Now that I have defined this, I will just say write, and then I go over to all the other networks which I have, and just write all of this data. And you would use the same procedure to add data to structures. Okay, so now what you can do is do the IFC export. So give it a number, give it some name, and we can export. Okay, so this now takes a little bit of time, depending on the size of your design, of course, but it's actually quite fast. Okay, and the IFC was created, and now I can go over to Navisworks. I can just select this this new file, and Navisworks will now refresh it, hopefully, and we will be able to see the results. So you don't have to use Navisworks, of course. It's an IFC file. You can use some different software. There are free tools for viewing IFC files. So it's not really an issue. You can find tools. You should be able to find tools without problem. Okay. And so we go to this my data group, and you can see the data we exported from the Civil 3D design, and essentially that's it. So it's quite simple to do, and very quick. And the important thing is you get all the data you need together with the 3D geometry in Navisworks or whatever tool you use for IFC. Okay, so we can continue with the next example. So I am going to show you one of the tools for editing pipe inverts. So again, just to emphasize, this is an add-in, so many of the, or most of the standard procedures will remain the same. Okay, so how you create a profile is the same, but we add some additional options to edit profiles. So for example, I can now select this profile, and I can start to edit it. For example, I can say I want to go from this first structure up to this point, and I want to have a slope of let's say 2.5, and now you see I see it directly in the picture how this will look. Also, everything is recalculated, so I see the terrain elevation, I see the depth and the elevation of the pipe invert for the starting structure and for the ending structure. And if I'm satisfied with this solution, I can just click apply, and a straight slope between these two structures is done. Okay, so what else can I do? Again, I will select a pipe run, so several structures and pipes, and I can say I want a standard drop on every structure. So this is something that happens. I don't know, if you have some gradual slopes in your terrain, you might want to have a uniform drop on every structure. So in this case, it's quite simple. Again, I can control it. I can insert, change any value I want. As soon as I change it, it's immediately refreshed. Also in the drawing. Once I'm satisfied, I just click apply, and that's it. I get I get my new pipe invert. Okay, moving on to the next part. A couple more interesting functions. So we have also the possibility to change adjacent sections. So in this case, you see that this pipe will be changed according to this slope. So I can maybe adjust this slope a little bit. I can also intervene directly, so to speak. So I can directly pick a height in the profile. I can do it also numerically. I just type in a value. As soon as I type it in, all the other values connected to it will get recalculated. So this seems a little bit too much. Let's say I'm satisfied. I just click apply, and it's done. And in the end, I just want to emphasize one important thing. So you can automatically update the structures when you update the pipe invert, or so depending on how you set this value. So currently it's set to automatically update. If I set it to false, and then I make some changes, for example, from here to here, and then I change it quite a bit, and I apply, you see the structures will not change. So essentially you control everything, and you can play with this, arrange it, and find the best solution for your needs. Okay, and let's move on to the final example. Okay, and I just want to say, if you have any questions, you can write it in the chat, and I will try to answer when I finish the presentation. Okay, so among all of these tools, we also have a simple trench calculation. But before I show it, I just want to show you again this spreadsheet module, just to emphasize that currently we have no calculation, so everything, all the values are on zero. Okay, so we need to do it first. Also, I would like just to show one thing. So I already talked a little bit about property set data. So this is let's say new type of data which has been present in Civil 3D for the past 2-3 years, let's say, and it's a very nice data type, if you want. So there's lots. So it's it goes to IFC, for example, and you can use it to add to labels. So it's flexible, and you can write your own data in it, and so on. So it's very nice, but unfortunately the use in Civil 3D is a little bit restricted, and there is so much more that you can do with property set data. So one of the things we made, I showed you already, was the export to the IFC, the improved export to the IFC. Another one is to show property set data in this spreadsheet, and then create AutoCAD tables, or export it to copy-paste the data to Excel. Another possibility is also to, for us, was to make a trench, a simple trench calculation using property set data. So we determine certain values like excavation volume and pipe volume and sand bed volume, and a few of these things. So we actually use this data structure that's built in Civil 3D for the past 2-3 versions. Okay, so if you still use an older version of Civil 3D, this is a good reason to upgrade to the newest version. Okay, so let's start with this simple trench calculation. So first you need to determine how this, or determine the typical cross section, let's say. So you need to determine how this trench will look like. And this is just a picture. The trench doesn't actually have to look like this, but this is just a picture that shows the different values which you can control. So of course, one of the first things you can control is the angle or the slopes for the sides of the trench. So in this case, it's I want to create a new trench, and it will be with straight sides. The next thing you can control, as it's also shown in the picture, is you can use a fixed width. So you can just input a value, or you can calculate it as a left offset to the pipe, then the pipe diameter, and a right offset, and so you control both of these values here. Then you can choose different types of bedding, so sand, concrete, or without. And of course, if you use bedding, you should have also the thickness of this layer. And connected to this, you also have the thickness of the layer above the diameter of the pipe. And the last setting I want to emphasize is this pipe angle. So this is actually a value where you can control where or how high the bedding goes. So for example, if you set it to 180 degrees, this means actually it will go to half diameter of the pipe. If you set it to 360 degrees, it will go all the way to the top of the pipe. And also, if you set it to 0 degrees, it will be only below the pipe. So, which would be, let's say, something more typical for concrete bedding. So you can change this value. So, for example, I will input 180. This means the bedding will go to half diameter of the pipe. Okay, and now I can move over to the calculation part. So it's actually not so difficult. So I have to choose my network. In this case, I only have one network. Then I need to choose my trench type. So this is one of the presets that was just made here. Then I need to select the surface, of course, because without the surface we cannot calculate it. And I can select the type of file which will be created for the report. So by default it's an Excel file, but you can also create a text file if you prefer. And okay, here's the path to the file. And then you can choose all the different values. So you can switch on or off some of the values if you want. You can change the precision if you want to add or subtract some decimal spaces. You can add some multipliers, automatic multipliers, or things like this. Also, you can control what we call excavation zones. So, for example, if you have terrain that changes according to depth, how deep you go, you can make various zones, and for example, it could be some type of ground that is very easy to excavate up until a certain depth, and below that it could, for example, be something a type of ground that is difficult to excavate. So you want to know how much ground you will be excavating in each zone, because of course it's connected to time and cost, and perhaps even different machinery and so on. So you can control these depth zones here. I input the highest value 100, which is essentially the same as saying unlimited, okay, but it has to be a number. Okay, and last but not least, there is also a data selection. So you can, for example, you can go in and you can say you want to, calculate the trench for a specific profile, okay? And the program will say, okay, you selected 20 objects within this, so meaning 20 pipes. And if I want to calculate it, I just need to run the calculation. I can save the report, which is an Excel file. So I don't want to append, I want to overwrite it. And I can open this report, and it will show me, okay, for this branch, the type of trench which I selected, and then all the different values, so pipe volume and sand bed volume, sand filling zones, then the volume of the various zones which I set up. In this case, I only have 2 zones, 0 to 2 and 2 to 100. So the total excavation volume and the cumulative excavation volume, and you also have a breakdown by stations. Okay, so you have the structure names, but you also have the stations, so you can control it quite precisely. And there's a total sum of all the values here below, and also on this sheet there's a report on the pipes that were actually used. Okay, so we can close this, and of course you can also so you can use any kind of selection you want. Most probably you will want to calculate everything. So if we now want to calculate everything, we can just run the calculation again. So this time it takes a little bit more time, of course. save the report. Again, I will just overwrite it. You can, of course, create separate reports for each profile or whatever segment of the pipe network you want. And I will open it, and again, it's the same sheet, again, the same spreadsheet, but now it's the excavation report is created according to branches. So we have a separate table for each branch. And again, in the end, the total for the whole selection, and again, breakdown of all the pipes, you know, names, diameters, and total lengths. Okay, in this instance, it's good to mention this Urbano Visio, this add-in for Civil 3D. It works equally well in an imperial system, in a metric system. It's not important. But whatever you use on whatever project, it will just work fine. Of course, it's tied in to what you have in Civil 3D, so it will use of course, your Civil 3D templates. It will use your part lists, your settings for Civil 3D, everything. Okay, how you have set it up, this is what the program will use. It does not bring any kind of data with it. It will just use what's installed. Okay, now if we go back out of the trench calculation, back to this spreadsheet control for Civil 3D, so excavations. Once again, you can see, for example, I can select a sequence here, and then I can also inspect all the calculation values. So, for example, this excavation volume, and here I can quite well see, okay, if I have this done this segmentation to zones, then I can see, okay, in this place I'm going to the second zone, so maybe I need to change something in my profile, not to go so deep, for example. So it's very, very easy, very simple to see. You see the values, you see highlighted this section in the screen, also in the profile. You can, of course, zoom into the profile and see exactly which part of the profile this is. Now you can, of course, use Urbano Visio tools to edit the profile. You can use the standard Civil 3D tools or something else. But what you have to keep in mind, of course, is this calculation is not automatic. So if you now make some changes to the pipe inverts, if you, I don't know, if you add structures or delete something, change the pipe diameters and so on, you have to go back to the trench calculation and recalculate it once again. Okay, so it's a calculation on demand. So that's different to all the other tools, which essentially change the Civil 3D model directly. In the case of the trench calculation, and this is true also for the hydraulic calculation, which I didn't show this time, all the data is written in the property set data, and so this means Civil 3D is not using it directly, but you can use it with Urbano Visio, and of course you can use it actually with any AutoCAD. With any AutoCAD, you can examine property set data for any object. Okay, so this is all from my side. If you have any questions, feel free to ask.
Yeah, thank you. Thank you, Mihael. That was great. We're still, we have no questions so far, but we're still waiting. We're here. We'll wait a couple of minutes. Okay. We have a comment and a question. So Dario says, so my question, are the labels on the structures also from the plugin, or are they all civil 3D labels, especially inlet and outlet sides?
They are all Civil 3D.
Okay, cool. I hope that cleared all the doubts. And okay, what I'm going to do now, if you don't mind, Mihael, I'll take the screen back. And so I'm going to start thanking everybody for joining us today. And I want to remind them exactly where they can find Urbano Visio and where they can download the trial. So this is our product page on Novedge.com. Just type in on the search tab Urbano Visio. It will pop right up. And then you can select to add the product to cart, or you can download your trial and check it out for yourself. And let me see. I want to remind you that I did record this presentation in its entirety. So if you want to watch it again, or share with colleagues or your firm and your bosses, you can do so by going to our YouTube and Vimeo channels. Thanks again for joining us today. Have a great rest of the day or night. And I'll see you all very soon and during our next Novedge webinar in the webinar series. Thanks again, Mihael. Have a great night.
Thank you.
Bye-bye.
Good night.